Hi guys, so in today's video we're gonna try to solve this equation. As we can see, this is an equation that involves logarithms. To solve this, first of all, we need to set the conditions of existence. So we know that the denominator is always different from 0, right? So we can set the denominator being different from 0. Also, we know that when we have log, the base must be greater than 0, right? So let's put the conditions of existence. So for the equation to exist, 7 minus log base 4 of x squared must be different from 0. Also, x must be greater than 0, right? Now 7 minus log base 4 of x squared different from 0. This implies that we can bring the log on the right hand side, so this implies that 7 must be different from log base 4 of x squared, which implies we can use the power rule to bring the 2 in front of the log, right? So this implies that 7 is different from 2 log base 4 of x, which implies the log, we divide both sides by 2, base 4 of x is different from 7 over 2. This implies that 4 to the power 7 over 2 is different from x, right? Which implies if we square both sides, we're gonna have that x squared is different from 4 to the power of 7, right? Now 4 to the power of 7, let's put it on the calculator. 4 to the power of 7, that means x squared is different from 16,384, which implies that x must be different from plus or minus square root of 16,384, which implies that x is different from plus or minus, let's see, the square root is 128. So x must be different from 128. Also, x must be greater than 0, right? So we have these two conditions. Now we can start solving our equations. So the first step we want to do is to make the same denominator here, right? So I want this one to be my denominator. So let's copy it down. Now this would not change, this one would not change, so we just copy it down. Then plus, we're gonna take this one here and we multiply it by this, right? So let's copy this, plus this times the denominator. Times this. Alright, and all equals 0. Now that we have this common denominator, we multiply both sides by this denominator here, right? this would allow us to get rid of this, because on the right hand side, if we multiply by this, we would still have 0, and on the left hand side this would disappear. So we are left with this equals 0, right? We can easily now solve this. So we're gonna have 2 minus log, we can use the power rule to bring the 7 down, so minus 7 log base 4 of x, then plus, here we expand, so we're gonna multiply this one by 7, then this by this, right? So we're gonna have plus 7 log base 4 of x squared, and then we're gonna have minus log base 4 of x squared times log base 4 of x squared. We can notice that these two are different. The log base 4, where x is here, is different from this one, and this is equal to 0, right? Now what we are going to do, this implies that 2 minus 7 log base 4 of x and plus 7 log base 4 of x squared, then here we use the power rule, so we can bring the 2 in front. We have minus 2 log base 4 of x times log base 4 of x squared equals 0. Now this one here, we can see that we have log base 4 of x, then log base 4 of x squared, so that would give us log base 4 of x cubed, right? So we can change all the signs, so this would give us minus 2 log base 4 of x cubed, which would be this one here, but with the sign changed, right? So then we're gonna change the sign of this one, minus 7 log base 4 of x squared, then plus 7 log base 4 of x, then minus 2 equals 0. So basically, in simple words, we have brought everything on the right hand side. Now here we have changed the sign, so it would be a plus 2. Now what we're gonna do, we're gonna let log base 4 of x equal u, so let u equal log base 4 of x. This would simplify our equation, so we're gonna have to solve 2u cubed minus 7u squared plus 7u minus 2 equals 0, right? Now we can see that this is a cubic equation. So to solve this, we're gonna have to first factorize, right? Now if we substitute 1 into this u, we're gonna have 2 minus 7, so minus 7 plus 7, then 2 minus 2, so 1 would be a solution of this. Therefore we're gonna use the factor theorem, right? So therefore u minus 1 would be a factor of this, right? Because if 1 is a solution of this, then from the factor theorem u minus 1 would be a factor of this equation. So we can divide this left hand side by u minus 1. That would give us 0 as a remainder. So let's copy this. This we divided by u minus 1. Right. Now, so we're gonna have 2u cubed divided by u, which is gonna give us 2u squared. Now 2u squared times minus 1 is minus 2u squared, right? And then 2u squared times u is 2u cubed. Now we're gonna subtract, so this would give us 0. Then minus 7 minus 2, so minus 7 plus 2, which is minus 5u squared. Then here 7u minus 2. Now minus 5u squared divided by u would give us minus 5u. So minus 5u times u is minus 5u squared. Then minus 5u times minus 1 is plus 5u. If we subtract, this would disappear. 7 minus 5 is 2u here, then minus 2. Now 2u divided by u would give us plus 2. 2 times u is 2u, then 2 times minus 1 is minus 2. As we can see, we have 0 as a remainder. Therefore, this can be simplified as u minus 1 times 2u squared minus 5u plus 2. So this equals 0. Now let's copy this. So we have simplified it like this. Or we could have also used the Ruffini technique, which is basically, as we know that 1 is a solution, we put it here. Then we put all the coefficients of this one here, which are 2 minus 7, 7. Then the minus 2 would be out because we put it there because there is no u in minus 2, right? So then we bring the 2 down. Then we multiply 2 by 1, which give us 2. We put it here. Then we add up, which is minus 5. Then minus 5 times 1, which is minus 5. Then we add up. 7 minus 5 would give us 2. Then 2 times 1 would be 2. If we add up here, we would end up with 0. We can see that these numbers we have here are all the coefficients of this. So 2 would be this, minus 5 would be this, 2 would be this. So this was a quicker way, but either way we would end up with having this as the factorization we wanted, right? Now from this we know that the product of two numbers would give 0 if either of them gives 0. So this would be 2u squared minus 5u plus 2 equals 0, and u minus 1 equals 0. This would give us u equal 1 as the first solution. Now we would have to solve this, which is we're gonna use the quadratic formula, which give us that u is minus b, so plus 5, plus or minus square root of b squared, so 25, minus 4ac, so 4 times 2 times 2, which is 16, over 2a, so 4. Right, so this is 5 plus or minus 25 minus 16 would give us 9. Square root of 9 is 3 over 4. Right, now this would give us two numbers. So 5 plus 3, 8 divided by 4, 2. 5 minus 3, 2 divided by 4, a half. So these are the other two solutions. Right? Have we finished yet? No, we haven't, because we have here u, and our goal was to find x. But if we go back, we let u to be log base 4 of x, so we just gonna substitute. So we're gonna have these three solutions: log base 4 of x equal 1, then log base 4 of x equal 2, then log base 4 of x equal a half. Are we done yet? Not really, because we want x, we don't want logs. So this implies that x would be 4 to the power 1, which is 4. So x is 4 is the first solution. The second solution would be x is equal to 4 squared, which is 16. Right? And the third solution would be x equal 4 to the power a half, which is square root of 4, which is 2. So our three solutions are 4, 16, and 2. Right, this is basically how to solve this logarithmic equation.